This video looks at binomial expansion and a little bit more. Last video looked at the binomial property, and today we're going to look at multiplying polynomials past that. So recall that a binomial has two terms, and expansion is a multiplication word. So today we want to multiply expressions of this type. A binomial times a binomial. So as with the distributive property, we have to be aware of integer arithmetic, sign rules. We have to be aware of exponent rules, basic exponent rules. And we have to be aware of like terms, and we're going to see that like terms are going to play a bigger part today than they did last day. So I'm going to use the same model we developed last class for elementary school. And this is how I work with my kids at home on how to multiply properly. So let's look at 38 times 42. I'm going to look at it in two different ways that are almost the same. So we're going to do the same thing. We're going to break these two numbers into more manageable pieces. And this one is going to be 40 and 2. And then what we're simply going to do is we're going to look at these four individual little pieces separately, and then we're going to figure out the total of everything inside. So this looks like the distributive property last day doubled up. So we put an extra stack on top. And elementary school students could do this quite easily, do their multiplication. And what they could then do is figure out the total of these two upper sections of our rectangle and these bottom, or they can fill in each column. And either way, what they're going to determine is 38 times 42 is equal to 1,596. So just as we did last day with distributive property, an area model for multiplication works, and I will say in this one it even works nicer than 8 times 36 like we did last day. Okay, so an elementary kid could do this in grade 4 or 5. You could also maybe even make it a little easier. Another way of writing 38 is 40 minus 2. So in doing this question, if you were a little bit older, maybe a grade 6, grade 7 kid, when you start to learn negatives and positives, well, we can set this up in a little bit different way, and maybe this way is easier. So then we're going to do the same process. We're going to figure out what each one of these little sections is equal to using our area model, L times W, one dimension times the other. And in this case, 40 times 40 is 1,600. 40 times negative 2 is negative 80. Again, beware of your integer arithmetic. This is positive 80, and 2 times negative 2 is negative 4. And in this example right here, what we should notice is in this particular example, these cancel out, and I could quickly determine this is 1,600 minus 4, which is 1,596. Now, if it didn't work out nice like this, 1,600 minus 80 is that, and 80 minus 4 is this. Either way, we get the same answer, or we could add down, and then we're going to subtract. Either way, we're getting the same answer. So this area model of multiplication works nicely when we multiply binomials times binomials at elementary school, but it works really nicely at the high school level. So let's look at the stuff that we want to be able to do, things you may or may not have done last year. So we're going to develop it based on multiplying binomials based on an area model. So all we're going to do is we're going to break each piece into L and W of our rectangle. And just as the example we just did, we're going to figure out what the area of each one of those little pieces, and then we're going to combine everything and figure out the answer. So 2x times 3x is 6x squared. 2x times 5 is positive 10x. 3x times negative 7 is negative 21x, and negative 7 times 5 is negative 35. Now, what I want you to notice right away is if we set up our monomials in descending powers of x, so this is how I always want to see things set up. We want the x stuff first and then say the number stuff second. Well, what's going to happen if we set up our box like that? Then these diagonal pieces are always going to be like terms for the ones we're going to focus on. And this is usually going to be our x squared term. Again, we're going to look at these kind of questions a lot. And this is going to be our number. So this is one of the things I want to develop in using an area model. We want to see consistently what each box, how each box is represented. So if we look at our idea of like terms, we have only the 6x squared term. Our x terms are plus 10 and negative 21, which is negative 11x, and finally we get this. So here's using an area model. Beware of our integer arithmetic, beware of our sign rules, beware of our exponent rules, and beware of like terms. And here's a way we can do a fairly abstract question and put the pieces together. Now, if we were going to use, again, the go fishing analogy that you might have learned in grade 7, grade 8, sorry, or grade 9, well, here's what that would look like. It would look, we're going to multiply 3x times everything in there, and we're going to multiply this everything in there. And what I hope you see is in doing a binomial times a binomial, what you should really see is we have just used the distributive property twice. This is what you've done. If we took away the 3x, we're multiplying the 5 in. If we took away the 5, we're multiplying the 3x in. Now there's a really nice word that I learned when I went to school way back when that is a nice way of remembering what to multiply. So this word FOIL is a little mnemonic that really just organizes your multiplication for you. That's all it does. It's not magic. It just kind of makes sure you keep track of things and you don't double up on the multiplication. The F stands for multiplying the first terms in each binomial. So there's my F right there, 3x times 2x, which is equal to 6x squared. The O stands for multiplying the outside terms in your binomial times binomial, which is 3x times negative 7, which is negative 21x. The I is the inside terms, and there it is right there. And in this one, it's 5 times 2x, which is 10x. And finally, L is the last terms. So 5 times negative 7, which is negative 35. And what I hope you see with this word FOIL, again, it's just a way of organizing, I hope you see that in the diagram to the left. Here is F, here is O, here is I, and here is L. So just like FOIL organizes multiplying binomial times binomial algebraically, an area model organizes it pictorially, and either way you get the same answer. And again, what we'll note, what I want you to notice is in foiling things, it's usually the O and the I, those inside terms, that turn out to be the like terms, or like terms. So both of these are good. I like the area model better, even though I learned FOIL when I was in school. Okay, let's have a look at this one. So here's our one dimension, 2x plus 6. Here's our other dimension, x minus 1. And what we're simply going to do is fill in all those little boxes. We end up with 2x squared, 6x, minus 2x, and negative 6. And again, what I really want to point out is across here are like terms, and when we combine our like terms, we end up with 2x squared plus 4x minus 6. And if we were going to do FOIL, again, remember FOIL is just the distributive property twice. If we're going to FOIL out the brackets, what we're going to end up with is this times this, and this times this, and this times this, and this times this. Now you don't have to write down FOIL every time, but it's a good thing to do until you get the hang of it. O is 2x times negative 1, which is negative 2x. I is 6 times x, which is 6x. And L is 6 times negative 1, which is negative 6. And again, here are our like terms. And when we combine those all together, we get this exact same answer as we did with our area model. Okay, one last one. Well, this is the and more stuff. Really what I want us to do a lot of is I want us to do binomial times binomial, because I'm going to ask you to undo all the stuff we've done. I wouldn't ask you to undo this one, which is a trinomial times a trinomial. But it's just this idea of how would you organize. Now, one of the things I want to say right off the bat is you cannot FOIL this out. That word FOIL only works for binomial times binomial. So if you were going to do this algebraically, what you would have is you would have 3x squared plus 6x plus 2 times x squared minus 4x minus 8. And you would just use the distributive property 3 times. You're going to multiply the 3x squared into all those things, and then you're going to multiply the 6x into those things, and then you would multiply the 2 into those things. And we'd end up with 9 items, and then we collect like terms, and away we go. Well, again, what I want to demonstrate is if you used an area model, something nice happens. Things kind of get organized for you. You don't have to hunt around for all of the pieces. So here's our 3x squared plus 6x plus 2. Again, we break them into their individual terms. We break a difficult problem into more smaller ones. So our exponent rules say that, that, and that. And negative x times 3x squared, negative 4 times 3 is negative 12, and x times x squared is x cubed. Negative 4 times 6 is negative 24. X times x is x squared. Negative 4 times 2 is 8, and our x. Negative 8 times 3 is negative 4, x squared. Negative 48x, and finally negative 16. Now the really nice thing about doing it in tabular form, our like terms are always diagonal. I didn't want to expand it out over there because it'd be too messy, but a table breaks a tough problem into an easier problem, and the other thing it does ahead of unmultiplying is it allows us to organize our thinking. So we have only 3 of the x4s. We have negative 12 plus 6 is negative 6 of the x cubed. We have negative 24, which is negative 48 plus 2, which is negative 46 of the x squareds. We had negative 48 minus 8, which is negative 56 of the x's. And finally, we have that. That's a really nasty looking thing, but it sure is a lot nicer in using an area model of multiplication. We're not going to look at this kind of question, a trinomial times a trinomial, much past this tutorial and maybe your first quiz. But again, notice how everything is organized nice diagonally. And that's our key ideas that I want you to be starting to think about. A box organizes, a rectangle organizes things in specific ways. And when I ask you to unexpand, we're going to come back to these area models.